Yeah, so I think we can start. Chris, you can take over.
Not a problem. So I think the structure for, I mean, the meeting today is not going to have a specific structure. The first 30 minutes or so we can use to unlock any of the challenges that you guys have had as it relates to Power BI. So maybe importing data, maybe doing any cleaning, relating the tables, cardinality, etc. And then we can use the other part of the session, the second bit, to perhaps cover some standard principles for Power BI and visualization in general. Yeah, and perhaps building onto what you will be doing, it would be great to explore how to annotate your charts and also how to add context as well as stories to your data. Yeah, so I'll open the floor to anyone who has had a challenge to highlight so that we know how to tackle that and share a few insights. Okay, so anyone with a challenge, anyone who's stuck on something for Power BI, so that we just run over it faster. Feel free to come off mic for the group work. How you are supposed to do the work in groups. That's an interesting question. I might not have the full answer, but I have a suggestion. Sometimes working in groups for a challenge can have its own problems. And so you need to, first of all, link with your group mates, perhaps even create a WhatsApp group or whatever channel you want to communicate in, and then divide the work. So of course, for you, the work is, first of all, having an understanding of the data, importing the data, doing any necessary cleanups and joinings of tables. So the whole concept is everyone should have a touch with the project, and it would be better if you do it live. So you can, as a group, the 3 or 4 of you can do the same thing, and then you jump onto a call, perhaps for an hour or 2, to polish. And if somebody has done an exploration that perhaps was not obvious to everyone else in the group, then it's great to, it's beneficial to share with the other group members, because you're working on the same project, you're working on the same problem. That way you will even get to learn more. And then when you're stuck, somebody else can unlock it for you. So that's the concept of the whole idea for working in groups. Then the other thing is, when dividing the work, here I don't mean there should be dead weights, but what you need to take care of is has everyone pulled their weight in terms of contributing to the questions you need to explore? Because there are many questions you want to explore here. So for example, for your group project, which is on air pollution, you have close to 6 questions or 10 that you want to answer. So you can divide that among yourselves and one person to do one thing. And if it's easier, then they can do maybe 2 things. And then the general cleanup can be all left to one person who will be submitting. But that's just a suggestion. It's not a one size fits all, unless Joanne, you have something else for them to consider. Oh, sorry, I was speaking on mute. Where do we find the questions? I think that's a good question on questions, which is interesting in itself. So from the communication that was sent to you, and I'm going to share my screen on this so that we get to be on the same page here. Okay, 1 minute. I'm still loading my email. 1 second. All right. Okay. So from the document that was sent to you here, I'm going to share the entire screen so that you have a view. From this document, the instructions are you choose one of these 2 projects. So one is indoor, one is outdoor air pollution. So it all depends with your whatever you prefer. So you're going to come here, you open the project. So log in to our world in data, read the context of the data story, and then download the data below each of the graphs, link the tables in Power BI, and then replicate, and then ensure the graph follow and answering the specific questions and summarize the insights as indicated in the website. So definitely you're going to come here, you look at what are we exploring, outdoor air pollution, read the article, enjoy the problem and the solution, and then you want to validate certain hypotheses. This project, this report has already gone through those. So long-term exposure to air pollution can have impacts on well-being, like things like your general health, your cognitive function, and then the first question is how many deaths are as a result of outdoor air pollution by year. So you're gonna come here and then you can so if you look at the table, this is the data. So these are deaths from high blood pressure for Afghanistan, like that in 2019. These are the deaths, diet high in sodium attributable to that, like that. And then these are the deaths, diet in fruits, unsafe water. These are causes of death. So these are the number of deaths. So what you're going to do is download this data, so you just download it like that. And they will ask you want to download the full CSV data. You can already see it here, right? So if I open my file manager, I can find it here. Number of deaths by risk factor, which is interesting because if I open it, you're gonna see something. It's not the same as it has appeared on the table there. So let me just show you that. Okay, there you go. So as you can see here, the data is not following the, okay, I'm gonna do that. but then the data is not following the same structure that you saw on this other side. It's been on the chart, this one, here, it's been pivoted, yeah? So, because if you want to see for, let's say, which year, 19, whatever, 1994, what this one does, it just gives you 2 years, 1994, 1997, like that. So, and then high blood pressure, diet, sodium deaths, like that. But this is for consumption. Now, the raw data is as it is here, where you have the year. For the first country, we are just going to explore for Afghanistan fully, 2019, fully Afghanistan, all the way up to 2019, 1990 to 2019. These are deaths from high systolic blood pressure, death sodium, whole grains, sexes, like that. So what you need to do is load this data into your Power BI, right? And then come up with that, sorry, this is death by risk factor. Okay, let's explore the whole 2019. What happened? I think we were only in 2019, yeah. So in 2019, this is the death. I mean, high blood pressure is the highest. It cost 10.585 million. It seems there are messages coming in. So my screen is still stuck on the assignment page. Is it just me? Is it just one person, or everyone else is experiencing the same problem? Because I think I'm sharing multiple screens. This is the problem, and then this is our world in data. Anyone else? Joan, can you which screen am I on?
Outdoor air pollution.
Our world in data, right?
Yeah.
And you guys got to solve the Excel document, I mean the CSV data? Okay, it's fine. So Chris, you can try join, or I mean unjoin and rejoin, because it seems to be a network issue, possibly on your end. So yes, so this is for the world. You can decide to just choose for a country like Afghanistan, and then it will reflect here Afghanistan, which is 37,000. But then you can decide to just choose for Africa region, which comes to 897,000. So you want to answer a few questions. You might want to just do the same like that's been highlighted here for the world. But then if I were you, I would actually explore further. So I would compare that, the deaths for the world by risk factor, and those for a country maybe like Kenya, you know, something interesting. So we want to see, yeah, unsafe sex. Okay, this is a bit weird because I expected maybe something like HIV, you know, you can't just say unsafe sex, but that's how the data was collected. And then air pollution, outdoor and indoor, is actually interesting that in Kenya it's the second, which is scary, right? Obesity is trending like that. So you can decide, okay, how about the deaths that have been caused by air pollution from 2019 all the way to which one? All the way to 2019. I mean, from 1990 to 2019 by indoor air pollution only. So it's all at your discretion, but this is exploring deaths around the world. So those are the questions. The whole essence of doing this analysis is to help you know when and what types of questions to ask. Remember, as an analyst, what you always need to know is, with data, there are so many questions that can arise. And so you need to look at your data and see, you know, what else can I explore? What would be of interest to someone? So I would be very much interested in knowing the trends from 1990 to 2019 in depth by air pollution alone. that you can explore there. So you've clearly seen the questions, right? Now, this is deaths from ozone and particulate matter pollution. So they're going deeper into the pollution deaths, right? And that's what I asked myself, and clearly it's been explored here. So if you look at the data, I think you're gonna see they've just chosen two, indoor air pollution now only, right? So it's the same data, only that we've filtered for these three: air, ozone, and particulate matter. And then we are trying to see the trend. And you'll clearly see here, and this will also help you learn. For these types of charts that are showing trends, where on the x-axis you have time, the kind of graphs you need to do are line graphs. So as you can see here, and somebody can be able to tell, in 2015, we had this many number of deaths, like that. So this has been the trend. And then this is the global distribution of death in terms of just mapping it out for density as a percentage. I think it's as a percentage of population, yeah. Share of deaths attributed to outdoor air pollution. So this is gonna require you to do some DAX, yeah, or some calculation, because if you look here, it's the same problem. It's just, your deaths for outdoor air pollution. But then in 2019, they formed 16% of the overall death, right? And then in 2019, it's 4% for Afghanistan. Now, if you look at the data, you can still extract it here. We can copy this, paste it here. Remember, I'm not going to save this because this is CSV. 2019, 1990, relative change, yeah? But what you want is deaths that are attributable to pollution as a percentage of all deaths. So this is household air pollution. Yeah. Wait, there's another pollution. Deaths that are from all causes attributed to air pollution. And then, yeah. So these are all the deaths. I'm going to just do a summation there for Afghanistan in 1990. Like that. So these are all deaths. And then wait, which one is the pollution one? So you will have 26 questions for every visualization you download. No, why 26 questions? Why did you ask 26? Let me know before I can answer. So it is S. So this is just gonna be S over that much. So it's 16%, right? Righty. So, okay, 16%. This is how much it's changing. Now let's just select for Afghanistan for a few years. There are 26 crafts. Really? No, you don't do both projects. You just do one. So you choose between the two. That's the idea. You don't do all projects. So let's check for Afghanistan 1990 and 2019. And we are interested in the last, yeah. So it's 13% and 16%, as you can see here. Okay, so I hope you're clear. You come here, I think there's something. Maybe I didn't choose the right column, but you're gonna need to do some calculations. That's what I mean there. And then, okay, so you choose one of the two projects depending on which one is of interest to you, either outdoor or indoor. And then you just need to draw the map. Okay, depending, but it would be interesting to answer the map. Here, for this one, it's for you to practice on mapping. And then you can, as you can see, this is the trend for Kenya. Anyway, your graphs are not going to look exactly like this. This has been generated by a different tool. That's something I also needed to highlight, because Power BI will have its own way of implementing charts. this could be Tableau. This Tableau, or this has been maybe an open source tool, so it has R Shiny here. It's been done with a different tool. What you need to ensure is your visualization is answering the same question that was answered here. So middle income, low income, world, high income, this is not interesting, but as you can see, there is a clear pattern. So for middle income countries, I think the deaths are more prevalent in these regions here. Your China, your India, your Saudi Arabia. This is outdoor air pollution, and it's very much as understandable. You've seen people in China wearing those masks because of excess heavy industry pollution. But as you can see, in places like United States, it's really not that much. Europe, there are countries with problems like your Kosovo, your Bulgaria's, but then your Eastern Europe is not the same, and then so this is question 1. This is question 2. This is death rates across middle income countries. The same problem, just been explored further. Then outdoor air pollution deaths by age. So this is very straightforward data if you look at it here. So this is 15 to 60-year-olds, 50 to 69-year-olds for each country, really. You can just decide to do it as of 2019. Don't bother so much with 1994, 19, whatever. Just do 2019. As long as you're answering this question here that has been explored, the burden of air pollution is prevalent in populations above 70 are not are clearly at much higher risk, and it does not result but from long-term exposure over their lifetimes. This can be explored by country to country, so you can clearly come here and then you change your country and then just check for Kenya. So here you have to kind of have this country by country exploration, because you want people to interact with your dashboard. It's a dashboard for a reason. It's not just a static graph. So this is very easy. You can just come download your data. Always download the data. Don't download something that has been done. So you can come here. The data is the data set already cleaned. For the most part, it's already cleaned. But cleaning does not necessarily mean it's in the format you want it to. So you're gonna need to transform it. So this one is, let me just check. Okay, let me see. These are deaths from all causes in 1,000 people. These are for 15-year-olds, for 5-year-olds, like that. So now, if I fire up my Power BI, let me do that in a second. This one, and then this is outdoor air pollution rates by age. Fine, I don't save that. I open here, import data. It's really not from Excel. It's gonna be from CSV. So insert, get data. Come here, CSV. It's under my downloads. So this is by age. I'm trying to answer that question. So it's creating a connection there. Let's see. All right. So I don't even need to, but I need to check. Okay. Let me just transform it. But you realize it doesn't have that much to be changed in the transformation phase. I mean, the code is ABC, it's here, and there's still some errors here. Some are empty. You don't care about those ones so much. For example, I'm sure the empty ones are the country, right? Like world, these ones that are not countries. So it's okay. I don't need to change that. Deaths from all causes, and of course you can always come here under view. You can column profile if you want to. Deaths from all causes, if I select it, it will profile the column for me, but then I don't want that. So deaths from pollution, You might want to even edit the title of your graphs, because it's the same here, but then what? Let me think about it. How do you transform your columns to just change the column names? You can't, I don't think you can do that here, but if anyone has an idea how to just rename the column names to something simple, because this is, but fine, there's another way to do it in the chart itself. So let me just escape. I don't need to transform anything, so I'll close and apply, just like that. Apply changes, the data should come here. Now the question I want to answer is deaths by certain demographics. So you'll see that I have outdoor air pollution here, and then if I check my charts, this is what was there. So clearly, it's not in the format I want, you know, under 5-year-old, like that. So you're gonna need to do some transformations, right? So for example, I want to do deaths. Year is gonna be a filter. So I can add a slicer there, and then I add year. And is that the slicer I want? Huh. Okay, let me just see slicer settings. It's not single select. I want it to be that other one, the one that is which other slicer is that? This other slicer, yeah, the line graph one. So I can just select the year I want. Now, as you can clearly see here, I can't do something like that because this is just gonna give me for 15-year-olds. So I need them all to be in one column, and then so I need to pivot essentially. I need to do some transformations to the data because this is going to be 15-year-olds, like that. So clearly, you can't just visualize it because if, for example, I want what that's 1,000 years. This data should be such that this is one column only, and then you are putting them into categories with values. What I mean here is, let me try opening it by age. So you can't necessarily visualize this, right? So you want it such that, let me take an example here. You want it to be in this format to transpose, to be in the format that these should be the columns. So this should be, you'll have something of this nature. Entity, so these ones are gonna remain, but then they will be copied across. So entity here, and then this will be the course, the age group, right? And then so now you'll take your age group 1, this is for 1,015 to 49 years, so that's gonna be there. And then this is 50 to 69 years. Wait, 15 to 52 years, this is going to repeat, right? Because it's in 1990, it's 1. So this is the number of deaths now, right? And then so this is gonna come here. And then in 1991, for that same age group, again, it's gonna come there, sorry. This is like that. And then the same age group. So that data has to repeat itself because it's for Afghanistan. So now in 1990, there were this many deaths. In 1991, for the same age group, there were this many deaths. As you can see, you have to transform it. Does that make sense? Luis? It's the same thing you'd do in your Excel. Maybe you'd insert perhaps something like a pivot table. Then it will be something like the entity remains the same column, or is it row? Yeah, Afghanistan row. and then you don't need the year, but you need the country. And then now you start piling your values. So that's deaths. Deaths. Okay. That's not exactly how it would go. This should be the title, or rather, this is not gonna work like that. So Excel can't do it. There are different ways to do it. I'm thinking of a much faster solution. I just need to escape that. Okay, typical of Excel to stop responding. So every year is gonna have, that kind of structure. The whole thing has hung. Yeah, but anyway, what I meant was there are certain scenarios where you're gonna need to pivot and transform your data to look in a certain way. Okay. Right, now let's go back to still our questions. That's deaths by category, and then these are deaths, how they are changing. So how are they changing? They've increased. Yeah, now this is how they are changing a country. I've tried replicating this kind of chart in Tableau and Power BI, and it's not easy. So yours, you can try it, but it won't necessarily look the same. So just be okay with that. Also note that this axis is going to, in China, there's an outlier here. So you're gonna need to have a logarithmic scale, logarithmic axis. Because if China is 1.4 million and this one is 1, if you were to plot it in real life, without doing a logarithmic scale, you see the distance between this is not the same as the distance between this and this. So it's gonna be skewed. You'll only have certain values there, so you need to be careful. That's why it's advisable that you know your scale. Death rates from outdoor air pollution have fallen for countries. I think this is answering the same sort of question. So death rate. Oh, okay, this is death rate. That's not number of deaths. So death rates per 100,000 people. So you have to divide by 100,000. So it's an interesting problem that's going to require you to do a bit of extra learning here and there. Let me just do something here. Okay. I'm working with another tool. I'm trying to see how best to pivot and unpivot the data. Just give me a minute.
Chris, as you're working on that, I had 2 follow-up questions just to at least help people understand more of these things better. So I've just dropped them on chat. The first one is, could you explain now to beginners what a logarithmic scale is and why we use a logarithmic scale, like in the case of China versus Nauru, in that sort of example? And the second thing also, as you're working on the pivots, can you explain deeper what is a pivot table and when should people know when to use it?
Okay. Thank you. So for a logarithmic scale, I think it's better if I show you some sort of like a picture. But from the example that you've seen here, when the data that you're displaying is different in terms of the differences or the skills that you're working with, then a logarithmic scale is useful. And especially if, the values, the disparity or the range of your values is very large. So for example, you could be having, in this case, is it Nauru? Yeah, Nauru having 10, like less than 10 deaths, and in this case it's 1 million deaths. So to kind of even out that spread, I mean the typical axis, the typical scale is where the intervals are even. So maybe you're moving from 10, 20, 30, 40, like that, right? So because of that large spread in your data, if you work with I'm forgetting the opposite name of that scale. If you work with a linear scale, right, it's those differences are going to give you, because they are evenly spaced, because those intervals are evenly spaced, it's going to be much difficult to compare them visually. So with a logarithmic scale, you're getting you're working with the log of your how can I put it, of your axis data. Okay, let me see if I have a better explanation. Okay, so I think I'm gonna just draw it here. So you have your linear scale where data is evenly spaced. So maybe 1, 2, or 0, 1, 2, 3, like that. So the distance between this data point and this, this measurement is the same. But in logarithmic scale, the measurement is the logarithm of that value instead of its actual value. So a logarithmic scale would be something of this sort, for example. So this distance is maybe 1 and 2. And then because we are taking the logs, the multiplication won't necessarily give you the same distance measurement. So this will be 1 to 2 to 3. And then as you move to higher values, as you move to higher values, then it's becoming much more squeezed. So the distance from maybe 1 to 2 is, in this case, let's say 10 to 100 is closer, is the same as 100 to 1,000. Yeah. Yeah. So they won't be having equal intervals, or rather they won't be equally spaced in a sense. Okay. Cyril, do you want to maybe provide an alternative explanation for those who've not gotten that understanding?
No, I don't think I have an alternative explanation. Probably what people need to understand, I can see Benson here saying, meaning the scale should not have equal intervals. I don't know, Chris, if you can just share the dashboard, the one, just the screen you're sharing on the Wildin data, so that they can actually see the log scale. So if you look at the y axis there, you can see like the space from 1 to 10 is equal as the space from 10 to 100 equal to the space from 100 to 1,000. So that they're using a log scale because this is not linear. It's not 1, 2, 3, 4. It's not 10, 20, 30, and the like. So this is a good example. And probably the only thing I would add is you use it when your data has significant outliers. So the difference between China and Nauru is extremely huge. So there's countries with 100,000 people. There's countries with 1 billion people. It's very hard to fit that in a scale. Otherwise, all these dots will be at the far end, and then you'll have 1, 2 dots on the other end. So you'll end up with a graph where if you're to plot it, you have a significant, let's say even 99% of your plots might be in that zone of, 100 and below. And then you have one extra outlier, which means like a significant percent of your graph is not really depicting the data. But in a log scale, you're able to spread the data evenly so that you can be able to visualize this sort of linearity. So once again, when you have extreme outlierness, you see this with country data, it is worth exploring log scales. And you can see here they're using a log base 10 scale. So this is 10 to power 0 is 1, 10 to power 1 is 1, 10 to power 2 is 100. So you can see they're using a log base 10 scale here to represent their data. You don't always have to use a base 10. You can use a base 2, you can use a base 4. Once again, it's about making it easy for you to visualize this data smoothly. I don't know if that makes better sense, but once again, you don't use it ever, use it with data with significance in outliers. So there's exponentiality in your data. So it's growing extremely fast as the numbers become huge. Benson, I hope we've answered your question.
Yeah. Thank you for that addition, Cyril. Now on to the concept of pivoting data. I think now this will make us highlight something on tidy data. So the best kind of data to work with is usually what we call tidy data. And the tidy data is data that the rows represent. So in this case, this is not a tidy data in the strictest definition of tidy data. In tidy data, the rows represent the observations, and then the columns represent what we call the measurements. So you want it to be such that, if it is something like a year, so this one will only contain observations relating to years. So 2019, 1994, like that. And then you want the measurement, whatever you're measuring. So in this year, I'm measuring, deaths by air pollution. So, this is cause of death, something like that, cause of death. And then this other one is, so cause of death, and then number of the value. So this will be the value of those deaths by that specific cause. So for example, in 2019, you'd be having cancer, and then how many deaths has it cost? Maybe 1,000, something like that. And then 2018, again, sorry, 2018, and then maybe you're working with smoking. So it's easier to visualize and work with tidy data. So that's the whole concept. So maybe this is 300. Now, this is long format data. It's long in the sense that if we had multiple values for 2019, okay, let me just see. I don't know why that's not working. Yeah, so if we had multiple values for 2019, we'll still just repeat 2019. We are still measuring maybe smoking again. It was 4,000. And then 2018, we are measuring for cancer, and it's 300 or 700, for example. So this is long format. Now, you don't always get your data in this format, as evidenced by this example here, where in this case, we have the columns being the measure, the category of the ages. So this is an attribute in itself. So this is something that we are measuring, or rather that we are distinguishing. And whatever we are representing is number of deaths, basically. So this is wide format data. So the way to transform it is to have these 4 column names, 4 columns here, be your columns, and then we have the value that we are measuring to be an individual column in itself. That way you can be able to measure. So let me show you an example of cleaned data. Let me see if I have one here. Which one is this? Okay. Not really. Upstream, no. Okay, let me just see by type, life expectancy. Okay, I think even in this case, there is that case, you might find a problem with the way the data is represented. Actually, no. So in this case, this is the difference between male and female life expectancies. So there's really nothing there. I'm trying to show you an example of, it's called dirty data, but it's not dirty in the sense that it has anomalies or those kind of problems. It's the way it's been structured. I'm not seeing diabetes. Let's see. Yeah, this is potentially clean, or rather tidy data. But let me just see. So as you can see, this is the age group, right? This is gender. So whatever we are measuring, whatever we are taking measurements of, and then the values are represented along this line, right? So this is rectangular data and it's tidy data. And that's why we pivot sometimes when the data is not in a tidy data format. When, for example, the observations are spread out as measurements, or columns for simplicity's sake. So what you pivot or unpivot. So this one, you need to pivot it to a long format. If it is in wide formats, maybe there are scenarios where you need to represent it in wide formats, but in analysis, I don't encounter that as often. If you need to pivot it in a wider format, then that's gonna be called unpivoting, you know. So it's not the same case as taking this data and then copying here and transposing. Let me just see. Because again, the problem you're going to have here is Afghanistan. You see, these are countries. This part here is okay, but then you only needed to unpivot the other parts, the depths part. So if you only had this, assuming, and this is maybe depths in 2019, or rather 1990 and 2019, this is tidy data, right? Because year is an attribute in itself that you're measuring. But is it really tidy? No, you still need to, make it such that this only contains deaths. So you're going to have a lot of repetitions in your data. So the reason sometimes this option is favored is the way it condenses the information. So you still need to pivot it. But then if you need to maybe store it, then you can unpivot. This is unpivoted data that you need to pivot. That's the long and short of my blabbing. Yeah, so by the very nature of what I've told you, pivoting is just rearranging the columns and rows so that you can, look at it from a different angle or different perspectives. You'll realize that in reporting, when you're doing your different budgets and things like that, that data is usually unpivoted. But then when you want to do your analysis, then you need to pivot it to especially long formats so that it's easier to analyze. Yeah, so let me find an optimal way of actually pivoting this data so that you get to see what I mean. I have to close it, and I don't need this to see this. Just give me a second. All right. So I have an hello. second. Oh, yes. So, yeah, you're actually right. Happiness, you're actually right on unpivoting. So that's actually the way to go. So you need to make it such that you have depth in the columns. I mean, the depth for the categories, and then now the number of deaths in those groups to be your values. Yeah. Okay. So just a minute. I need to open my transform window. Okay, it's taking a bit of time. Okay. So okay. So you'll come here. Just a minute. What are these changes? Discard. You'll come to your transform data. Then you'll just select those columns the same way Capness has shown to unpivot. So you can decide to select this first two so that you unpivot the others. But I think the best way is usually to just select the ones you want to unpivot, then you transform those, and then you just select unpivot. So this is how it will look like, right? So of course you can decide to extract the first few characters of your column so that it becomes much cleaner. And I'm trying to see the number of words here. I can transform by extracting characters, last characters. So maybe we just want the last 10. Let's work with that, for example. Right? Okay. And let me see. Yeah, okay, it's close to that. It's close to answering what we need. So as you can see, now Afghanistan has been repeated this many number of times because of the categories we have here. So we have 5 to 49 years, 0 to 69, 5 to 14. Okay, wait. 5 to 14 years. And I don't think it's 5. Maybe we need to just change the number that we are taking. Let's take 15 instead. Yeah, okay, it's actually 5 to 14. So I think we can choose number. It depends. You can say text maybe between numbers. So if you find your first number there, it all depends on how you want to take it, but then you'll miss this under 5. So let's just use those categories to make more sense of this. So this will be those aged under 15, I mean 15 to 49, 50 to like that. So it's repeated all through, and then the value here. So of course you want to give this a different name. You can decide to edit it here, but you can also just rename it to something much more useful. So, and then the value here is it deaths per 1,000, right? So you can decide to rename it. Where's the rename? Yeah, like that. So that you can always edit your queries easier. So death per 1,000 people. Is it 100,000? 100K, for example. So, and then this one is whatever attribute that you're measuring. So then you will come here, you apply it. And so you have your 2 columns. Things are going to change here once we apply our changes, as you can see. So as you can see here, so the attribute that we are working with is, those number of deaths. It's not going to be so neat as we want it to, but as you can see, we can now visualize the number of deaths per 100,000. And of course, you choose your relevant column there, you put your filters, etc. Okay, so I think that's sorted. What else? Yeah, so this is fine. This is for map data. Let me see if you already have, okay, because you have countries, Power BI is smart enough to know that it's going to generate, what do we usually call those? Yeah, it's going to generate your coordinates or your latitude and longitudes for these countries, and you just choose the correct map there. So that's nothing complex. How dates are from outdoor are changing. We already talked about these. You just need to keep note of that logarithmic scale element. Which one was this? Same problem. No, okay, let me see. No. This is a death in 1990 and 2019. So we're just comparing 2 years there. And then exposure to air pollution across the world. This is again map data. You can always download, but it's nothing different from what you have up there. This is more like exposure. So it's not, I don't think it's death. So it's a different issue altogether. What you need to make sure is you're answering, okay, maybe there is a cause, not maybe, but exposure to particulate matter, I think that's what we calling PM, is what is directly related to death in not deaths, but deaths attributable to ozone pollution, so particulate matter. So this is air pollution, exposure to particulate matter as such. And then this is above WHO limits. They have the limits set out there. Again, map data, nothing complex, I mean, nothing new that we need to discuss. Exposure above the targets. Well, you might want to do this, but once you've explored the particulate matter distribution and trends, you can opt not to if it's not answering the critical questions. This is exposure again across countries. Yeah, this is where it gets interesting for comparison between countries. So you can decide to use a country like UK and another comparison country. And you have those charts side by side, not side by side, but yeah, side by side. So it doesn't have to be superimposed on each other. so that the reader can clearly tell the difference. How to make progress against pollution. There's that linkage. Yeah, you can decide to go to these depths of exploring. Another question that would be critical is when you're linking it to population data and also GDP data. I think that's been done here. So here they've chosen a few countries. You can decide to use our Kenya, some country that is having the same comparison figures, and then the outliers like your India and your China. Yeah. London. So this one might not necessarily be relevant to us, but you can choose a country, I mean a state or a city that is of interest to you. So like was provided in the instruction here, you don't have to do all the questions, especially those ones that are dealing with particulate matter and the granular details of ozone layer. You might want to just restrict yourself to air pollution, the outdoor air pollution element. So much as the article has gone into details of all these particulate matter exposure, those are add-ons that you can work on based on your interest and the time that you have. But the critical ones are those ones that relate to depth, the exposure levels, and how they are changing per country. So you can actually decide to cap your analysis at this point, but make sure you're answering the critical questions. And if you decide to cap it off, to cap your analysis there, then within these graphs, go a bit deeper. Just don't replicate this. Explore something else that was not necessarily obvious. So you can decide to do this chart and compare the Kenyan figures. So you can have the Kenyan ones as a percentage of the world depth. You don't have to be Kenya. It could be Africa, for example, as a percentage of the world depths, etc. So something just to consider there. Is the same, that was outdoor air pollution. We also have indoor air pollution. It's the same sort of process that you're gonna use, that you're gonna take. There's, these are deaths by pollution, the same process, the same problem. But indoor air pollution is a bit different. Indoor air pollution is more prevalent in low-income countries. And that's something that people don't think about as much. So for example, during COVID, you'll see a spike. Okay, household air pollution by deaths. That's quite different. But during COVID, yeah, I think the peak of COVID was not 2019. There is potentially a spike because people are staying more indoors, and so indoor air pollution is causing more diseases. Yeah. All right. I think that's been it. Again, let's use, I think we have less than 10 minutes remaining. Let's use those to unlock any challenges someone might have faced when it comes to loading the data and preparing, so that we make the most use of this session. Oh, okay, I see a question on the chat around logarithmic scale. So you'll come here under your axis, and then there's usually a way to select. Let me just see. There, you will you always have a number of options. Okay, x-axis can't necessarily be logarithmic scale because that's there you're dealing with categories, but y-axis, you can select it on and off, as you can see here. So if I toggle it on, you can see there is a difference. So it's as simple as that. Hopefully I've answered your question. And then you can, decide to select your ranges, etc. But as you can see, we are working with base 10 again here. So the differences are not as pronounced as compared to when we were working with a linear scale. Of course, it's always also recommended that you put your data labels, especially in these cases, and change it to something like what's that about? So data labels, and you want it to be displayed in maybe thousands or something like that, or you just don't want them to be in any values, which is quite ridiculous anyway. So you want it to be in certain okay. Locating partners. John, I'll let you advise on that.
Okay. If you're finding it hard to locate your partners, I will share the document of the groups with their emails. Alternatively, I think everyone is in the Slack channel, so you can add them or you can directly DM them.
I think this is just what I'll add, and probably we just need to do that over here right now. I do understand that some of you have tried reaching out to team members, but people are not responsive. So ideally, at the end of this call, we just want to know who are the active members in each particular group, and we can do that extremely fast. And then the way forward is if you're already 2, 3, or 4 people. Once again, if you're 4 people, that's a full group, so you guys are good to go. But if you're 2 or 3, just start the project. Don't wait for the extra team members. Do it as 2 of you. When you're submitting the project, we'll have an entry to just say these are the 2 team members who participated in the project. So that's the code. You can't look for a ghost member for the whole week. We understand that. You can try reach out on Slack. You can try reach out on email, which Joanne is sharing over there. But if you don't hear from them by Thursday, then don't let that detract you from continuing with the project. So that's the first thing I am going to mention, because I do understand in group projects there will always be that. But once again, we'll consider those who participate in the project when it comes to the submission. Okay. So probably Joanne, as you're on that, I don't know if it's Joanne or Chris sharing the screen. We can just do a quick check-in, group 1 to 10, whether everyone has found their team member, and then we can call it.
Yeah. Let me just download this. We can check in right now.
Yeah, I think we can just start. Group 1, Esther, Lois, Joseph, Evelyn, any of you here? Just a quick one, I want to do it very fast. Okay, Lois, feel free to tell us. You guys have met everyone. Who have you not been able to peg in? Feel free to unmute.
Hello. Joseph. We haven't found Joseph. He's using a different name on Slack.
Okay. Joseph happens to be here, any chance? So once again, reaching out to Joseph over there. Okay. So that's well noted. Thank you, Lois. Let's go to group 2, Judith, Mandela, Alice, Timothy. Anyone who's around? Team, feel free to cooperate. Kindly unmute any person you've not met yet in your group.
We've not, but nobody has reached out, so we're just there. I don't think there is anything that has happened in our group.
Okay, I can see there's Alice here. Can you make sure you share contact here? I don't know if Mandela and Judith are also here. Okay, so in that group, we're putting 2 active people, right? I can see Alice on the call, so I'm guessing you two should already meet. So Alice team, and then we're seeing Judith and Mandela still not found. Kindly, if you once again, if you find these team members, what I'm doing on my end is I am checking the ones who are active. So if the inactive team members are able to join in before you guys start the project, you can notify me. So I'll just know. So for group 1, the active members are Esther, Lois, and Evelyn. Joseph is inactive. For this one, it's Alice and Timothy. The other 2 are inactive. So if the inactive people join us, that's when you kind of notify us, which should be fine. Okay, let's go to group 3. Michael, Diana, Vivian, Lewis, any of you? Want to move fast? Anyone? Yes, Lewis, I can see. Feel free to tell us who's active in the group.
Hello? Sorry?
Yes, just tell us who's active in the group there. That should be fine. Okay, so actually it's okay. Thank you for being proactive. Yeah, I can see Diana said we're only missing Vivian. So that's okay. So group 3 is well set, 3 people. Group 4 has been proactive as well. I think the only person you guys are missing is Caroline. So that's fine also on group 4. Okay, let's go to group 5. Once again, if you just want to type as well on the chat before we reach you, that would be great. Go for it, yes.
Group 5, we haven't reached Christine, and Joy is a bit, yeah. But actively, we have Catherine and Benson.
Okay, so actively Catherine and Benson, that's fine. That's okay. Let's go to group 6. Team, you're being requested to check your Slack. Your team member reached out.
Pardon? I reached out to Chris. Hello?
Yes, Cynthia.
So the only person I've been able to reach out is Chris.
I thought you were talking about Chris, the instructor, but it's fine. This Cynthia, are you Cynthia Ngende as well?
Never.
Okay, that's fine. So Chris, it's Chris Peke. That's fine.
Yeah,
okay,
but
so
I've
you've
seen
not found and Joffrey. Okay, that's okay. Let's go to group 7. Anyone from group 7 around? 3 more groups, guys. Let's finish this. Okay, seems like everyone is inactive there. I did see Fardosa in the call earlier. I don't know what happened. Yes. Okay, let's move to group 8. Time is not on our side. Group 8, any one of you here? Naima, Esther, Joy, Sylvia?
Yeah. So I reached out to my team members on Slack. Only Naima replied. She said she left.
She said she'll?
She has left.
Okay. I can't hear you so well. Do you mind typing? Okay, as Sylvia is typing, let's go to group 9. Vivian, Victoria, Seth, Prudence. Okay, so Naima said she left. So are you alone, Sylvia? Type if you're alone, and then I'll assign you the groups with the very few active members, which should be fine. Okay.
Yes. Currently,
Okay, so I'm struggling to hear you, but I think I've gotten the message. That's okay. That is fine. Vivian, Victoria, Seth, Prudence, any of you here? Okay, no one from group 9. And then let's go to the final one. Mary, Likam, Jackson, Mwebe, Masimwangi. This all seem like Zindua students. I don't know if any of them is here. So as we can check in, they're all core students there. All of them seem to be core students. Mwebe, ML, and the like. So that's fine. That one we can do a side check-in. Once again, I'll just do one last check-in. Vivian, Victoria, Seth, Prudence. Anyone? Group 9? Okay, and then a final check-in, Joseph, Pardosa, Michael, Musimi, Ian Wiruri. Okay, so Sylvia, let's make your life easy. Let me see which team here has 2 people. People who are not confirming. Okay. Okay, Alice and Timothy, do you guys want to take in Sylvia into your team as well? Alice, Timothy, I know you guys are reaching out for the first time, so I'm guessing you're yet to get started. So Sylvia, you will join team 2. So Sylvia moves to team 2. Okay. That is okay. I think that culminates the check-in. Our whole goal is to make sure that you have active members in your team, and that if you don't have active members, we assign you to other people who are active who are struggling to find the team members. I'm guessing only Sylvia has been affected like that. You now have a team, so don't worry about it. Once again, the way forward is we're doing the team project. Then you do the submission as a team, and then afterwards you just issue the certificates based on the dashboards you guys have created. Those who do not participate in the team projects will have to do their own individual projects later on, all through. So that's just going to be the end update there. Once again, if an inactive member is able to reach back to you and join your team, kindly make sure I know. Otherwise, in my books, the people we've ticked here will be the people we prioritize and know are active in the group. For groups that, for all the guys who are inactive, if you want to join a group, just if you want to pass the message, let them also reach out. But if all your group members go inactive, drop us a DM so that we place you in an active group so that you're not affected by your group members. So once again, don't suffer. If you're alone, don't suffer. If you're 2, 3 and above, go ahead and start the project. That's okay. My final question is there anyone on the call who does not have a group? Like out of the names we've gone through, you don't have a group? No, it's unlikely to happen.
I can see Mandela on the call.
You can see Mandela on the call. Happiness, you don't have a group.
No, I do have a group. I'm asking about, do we get an extension of the time?
That's a good question. First of all, before we talk about extension, Mandela, yes, do you have a group? Like, or rather, your group does not, I think you're one of the groups that no one was active. Or where's Mandela? Mandela, you're in group 2. Group 2 is not reaching you. Okay, Alice team, I can see Mandela here. So that should be the missing member, right? Guessing you guys have a Slack group as well. Okay, sawa, Captainess, over to you. So Alice team Mandela, and then we'll move Judith away from that group. So Sylvia joins you and that completes group 2. Awesome. Judith is a Zindua student, so we can find something for her, nothing much. Okay, sawa, Captainess, over to you.
Yes, it was a kind request for now that we have a better understanding of what is required. Like for in our group, we were struggling to know, so what are the questions? What are we answering? Now that we have a better understanding of what to do, could we be afforded some more time to do a good job?
That's a nice way to ask for it. I think it's viable. So to do a good job, yeah. So we hope the job will be good for sure. I know Monday was the core deadline there. We highly advise you to do it as soon as you can. But probably what should we do? Should we do end of next week? Is that more than ample time? Okay, so once again, I know this holiday is the best time for you to consolidate your team members and work on it. So try crash it on that. But what you can do is let's do till end of the next week. So that will be by Sunday, 11:59 p.m. I'm guessing that will be April 7th. So April 7th, 11:59 p.m. Team projects are due. But beyond that, if you do not participate in a team project, you just have to do your own individual project. Yeah. So that's okay. Any final questions in regards to the projects and all?
Yeah, Cyril, I think I saw something. Someone asked on how to open the project if you need to log in. You don't need to log into the website. I think that that was a small error, but it's not about logging in. Just clicking the link, and in a sense, you're able to access the data. And for those who didn't catch it, you download the data by just clicking this download button here. So I hope that's now clearer.
So you don't.
Hello, go for it.
I'm saying, so you download for each of the items, like that's for that particular graph. You go for another one. You download sequentially.
Yes, but not.
Like,
You'll realize
like
that,
for example, okay.
You'll realize that this data on depth is perhaps the same data that has been used here. So you see, you don't need to download this one as well. All you need to do is transform it so that you can use it to visualize the map. So that's where you even have this table thing here. Death rates from indoor air pollution. Again, the same data, so you don't need to download the whole information. As you can see, it's just been derived from that. But when it came to age, you realize that was something else. So, and then this one, they've just filtered. So if you download it, you'll realize it's containing the whole list. But then in the visualization, we have, let me see if it's by region. Yeah, in the visualization, it's by region. So it's still the same data, still the same deaths from air pollution. The other one is the broader one. So it's the same data, only that it's been subsetted into different values. Highly encourage you to download individual if at all you're not clear on the linkages. But from what I can see, from my experience, the initial data has most of the categories that you want to explore, apart from this one that now has something to do with ages. Yeah, the under 5 years, like that. So I hope I've answered your question. Deaths per 100,000, this is a different data in itself. So you might want to download to the extent those data sets are different. But that's why you also have this table here to just check. Okay. 02? Were you answered?
Yes. Thank you. I think I've got it.
Any other question with regards to the project? Okay, something I wanted to add is where you add your insights. Ensure that in your dashboard, because anyway, this thing is, once you expand it, it's gonna be huge. So you can always add your texts, depending on where you want to place it really. It's that's on you. So you can add your text boxes somewhere there, and you move it depending on how you will want to structure it. So maybe notes there. So just explaining what, and sure, you have to have that part, the insights part, something like that. So ensure you have them, and it could be your bullet points like that, etc. But you can have them on the side, you can have them below your charts, but make sure you're answering questions. And then don't leave your charts with things like the sum of debts per 100 attributes. No. Or definitely you have to format your charts. They have to look good, right? So maybe debts per 100,000, something like that. And you choose a similar theme all through. So if it's maybe in the middle and you want your text to be certain colors, ensure you have something that looks good, something that is neat. Even your access, don't leave it like sum of debts per 100,000, just name it correctly. So some of those cleanups, formats that are going to make your visualization appealing. That also shows that you have pride in your work. But if you do something shoddy, then these are visual things. So as you can tell, the way you present it matters just as much as the information you're presenting, right? So for example, this is a simplistic one, but as you can see, there's some order to it, even if you have tables like that. So anyway, this is not the ideal, but as you can see, there's some order to it, and that's the same thing I'd want to encourage you to also take a keen consideration on. Other than that, I have really nothing else to add, and I wish you all the best. Back to you, Joanne.
All right. Thank you, Chris, for that insight. Thank you also, Cyril. I just want to wish you all the best as you tackle your project. And yeah, I don't want to take much of your time. So you have a good night, everyone, and all the best.